Today it's Thursday, February the 22nd, and this is the first video for All Road Cables, where we have a 6100 board and an ISO. On this particular case, the customer has a star converter. We have all 6 SCRs connected to the common cathode to make the positive, and then here we have the neutral on the negative. What we have here is a simple full-way rectifier where we have a firing board, we have 6 SCR, wouldn't be able to see this, and we have a regulator board. So there's our 6100 board and we have a regulator board. To Enerpro, it's important to take a look at this drawing provided by the customer, LHD-450/13 000005YL on sheet 3 of 6. What we've done is we've verified the connections, verified that everything's good. Looking at the original fabrication orders for ISO VLCL2 serial number 1051, which is right here. Keeping in mind that this is set for, or this board was set up for 0 to 75 millivolt of feedback, when we normally have 0 to 50, but the concept is the same. And looking at serial number 31298 for the 6100 board, and here we have it. And so we have the original fabs. A couple of things. First, we notice here that this board takes J5, and that's where J5 takes the phase references from the 3 phases. The original board did not have J5 installed. Matter of fact, it was meant to have the phase references obtained from the cathode of 3 SCRs, but of course that couldn't be done here, because here in this particular application, in this particular topology, all SCRs are commonly connected to each other, so we wouldn't be able to get the phase reference. So I imagine that this board was modified for J5, which is good. The other thing that we have here is that this board was originally configured with a transformer and with J4. The customer, it's apparently using it with a, I want to believe that it's 24 volts AC between pins 1 and 2, although here there's a 24 volts to 0. Unless the board was modified and it's used as 24 volts DC, that's something to check, something to verify that the board is properly powered. And on the schematic for the board, it'll be a good idea to look at J3 position 6 and verify that the board's got 12 volts and that the 12 volts is solid and constant throughout the entire operation. That's really the biggest concern. Check the input and the output, they are good. Once we have the phase reference, we check the connections between the 2 boards, they are correct. We also notice that the customer is using the current command and the voltage command to control the process as a current limiter and the anneal setting. And we verify the start stop, and we verify the connections to the voltage feedback and the current feedback, which again should be coming from a 0.75 volts DC. So as far as the connection diagram, the board setup provided for that the board was modified for the 24 volts AC, or 24 volts DC. If it's 24 volts AC, it's fine. For J5, then these 2 boards should work just fine. This is the end of this first video.